Hello, my name is Tonzo. In this video, I'd like to show you some practical ways to improve the modified index in CFA by using Mplus software. There are several ways to improve the modified index. That's why first of all, I'd like to show some PowerPoint slides to make this presentation clearer. First of all, in the model, when we run the CFA model, we should remove the problematic items. It means some item it has very low loadings, pattern loadings. It means less than 0.4 or 0.5. If these standardized loadings are very low, it means it can increase the mixed fit or the poor fit. That is why we should take care. And also, in some model, some items have some low pattern loading, but still significant, it's pi. But we should also check some non-significant loadings. That is why we need to take care. And also, very low R square. R square means standardized loading square. It means how much variance between the observed variability and the latent pattern. That is why we should check how is the value of R square values. It means weak items are the most common source of poor modification in CFA. And the second source is we should check modification index when we run a Mplus model. First of all, we need to check for error variance, error covariance. It means in this, for example, Y1 with Y2, it means these two items are highly correlated. At the time, we need to coordinate within the same patterns. And also some items had wrong patterns. But for example, we follow the previous questionnaire. At the time, we use the same item, the same patterns. But in this sample or in this context, these items doesn't belong to this previous pattern. At the time, it has problem, it has cross-loading. We should take care of this one as well. And also we perform these modification index suggestions. We should check this item has similar wordings or same meanings or overlap concepts or something like that. We should check it. But even though we should check, we should follow the theoretical foundation. If theory says we should follow. If not, we should find different ways. That one is inspect residuals. Residual means look how much difference between the observed data and how the theory says. This is the difference. It means this is the residual. We should remove the higher residual. Residuals mean the gap or the difference. Higher difference is very bad poor fit. That's why we should remove greater than or equal to 0.10 or 0.15. It means the residual value should be the lower, the better. That's why we need to take care. When we check the residual value, we should look for the residual correlations in the residual output. It integrates missing relationships of poor item fit. The fourth one is the correct estimator, continuous variables. Our data is continuous and it is a normal distribution. We use ML, maximum likelihood. If it is continuous, our data is not the normal at the time. Maximum likelihood, robust. And also ordinary, our scales are linked with the least square mean some variance. And also, this is the Bayesian model, complex small sample Bayesian model. But this one we rarely use it. Wrong estimator, misleading model fit. That's why we should take care. And also, the sixth factor is we should examine pattern structure. Some patterns are highly correlated, greater than 0.85. It has a problem. It means the two patterns are highly correlated. It means the same concepts, the same items or the same concepts, and that's why we should take care. we should restructure or we should modify the items. That's why it means higher correlation, it means misspecified structure. We should reassign the items or add some other cross-loadings or merging or combining some patterns. If theoretically justified, we should take care. And the last one is consider sample size or data quality. Some samples are unstable estimates, it's quite difficult. And also missing data, so it's small sample size. Some small sample size are difficult to get the good motivate. And also missing data we should handle properly. But there's no recommendation for the enough sample size for running this CFA model in Mplus. But some structural equation model researchers or analytics, they suggest it should be better than 200 participants. That is why, based on these practical ways, we should try to improve how to improve the model fit. Now let us keep going. Mplus software. In this Mplus, let me show you opening one import file. I have already saved the data. Then this is the data set. This is the data set. There's 20 items from 1 to 21. And also these 21 items I divided into 5 patterns. This is the theoretically divided. We call it Mplus model. The first one is empowerment, success, interest, caring, motivation. These are 5 patterns. We divided these 21 items into 5 patterns. These are the data. Let's keep going to Mplus. Here we run the CFA model. This is my save file. I plan to make a YouTube video desktop from desktop. This is YouTube folder. The file name is n11dat file. In my previous video, I'm already explained how to save the dat file from SPSS to dat file. You can check it out. And also the format 21 items. All are 1 digit. That's why we mentioned these are all 1 digit. That's why in Mplus it is 21 items at folder 1.0. These are variable names. From 1 to 21. Missing values. We should check the missing values. But I'm already checked the missing but no missing value. But for confirmation, I set the missing data as minus 999. In my previous video, I already mentioned the missing value. We can say different types of numbers, but it should be different from the common data set. From the common values from the data set. These are the used variables. I use all 21 items again. Estimator, I use, this is a Likert scale. That is why weighted least square means variance. The estimator, I use it. These are 5 patterns. Pattern 1 from M1 to M7. F2 mean U1, U2, U3. F3 mean S1, S2, S3, S4. F4 mean I1, I2, I3. F5 mean C1, C2, C3, C4. All are 21 items into 5 different patterns. I plan to run a standardized model. That's why STTYX. Let us save it. Actually, I'm already saved this one into N1. We can check it out. It is N1 already. I save it. But if I save it again, we can say replace the name. the same. Now I will run it. It is a problem. Let me check it out. M1, unknown variable M1. This unknown M1. Let me check it out. Sorry, but the names are M1. But in this one, I did not use M1. That's why M1. I should use it. Let me see if I can run it again. Yeah, modification. Let me check it out. 889. CFA value, TLI value a little bit lower than the recommended fit index values. RMSE a little bit higher, 0.07, but it is acceptable. SRMR, it is acceptable less than 0.08. But now we want to check what item has the problems. This let us check the standardized model results. Here I want to some items F1 by here. These are pi padas. See, this pada M1 has very low pada loadings, but it's still significant. Can you see it? This one M1 low pada loading, but others are 6, 4, 6, 7. Others are others are fine, but we can check it out by diagrams here. Just the D1X. Let me show only significant, but all are significant. See, M1 has very low pada loadings, but others are acceptable. 6, 6, 6. This M1 is a different problem. We already mentioned in the first one. We need to check it out. Remove problematic items. Very low, less than 0.04, sorry, 0.40, 1.0, but still significant. Let us check R square. How is the R square values? Let us check it out. R square here, M1 here, M1 very low and also not significant. It means this M1 is really a problem. That's why we were trying to remove it. We add it, but we will remove it. I will save it and run again. When I run it out, let me check it and modify it. A little bit increase from 889 to 897. TLI is still low. RMSE is the same, 0.7. Chi-square values are still high, but it is acceptable. Chi-square values and TLI values are acceptable. But solving the problem by removing items, removing M1 items, it cannot solve the problem. That is why we were trying to remove the second one, modification index. Let us check the second way. I will remove modification index. That's why we were trying to run modification MODINDICES. Modification index should be around 10 and above. It is problematic items, problematic correlation. That's why I can recommend 10, but mostly we can all as well. But and the term is enough. We don't want to remove very low correlations. I will save it and run it again. Modify it. Let us check it out. 897 not improved enough. Sorry, the same. This is a modification index here. Modification index. But these are patterns. These are pattern cross-pattern suggestion. But mostly we run the pattern based on the theory. That's why we were not consider this one, but we will check with item. Here we will copy it. We will copy it. We will copy it and put it in Mplus. Put it in Mplus import here. I will put it here, model in the model. But we should take care when we run the model. Can we remove it? These error covariance are, these errors, measurement errors are correlated by this way. I will save it and run it again. Here modified require increase. It is acceptable. But we should check it. Its theory says this. Its theory says the same or no. When I check it in the diagram, here I correlated different patterns. For example, M4 to U1. It's a different patterns correlation. We should not correlate like this way. For example, M5 to M6, I correlated. It is also acceptable, but within the same pattern, we should correlate it. But different pattern, we should not correlate. For example, U1 and U3, I correlated. It's okay, this error within the same patterns. But different pattern correlations are not theoretically correct. Theory said these, as for example, S1 to S4 are the same patterns. If we can correlate within the same patterns, but different patterns correlations or error covariance, we should not do different patterns. That's why we will remove these correlations or different patterns. We will use only the same pattern correlation. The same pattern correlations we will use only. That's why we were trying to remove different pattern correlations. Here, for example, C1 and S1, it is a different pattern. We will remove it. I1 and U1, it is also different pattern correlations. I will remove it. M1 and M4 and U1 different pattern correlation. For example, U1 and U3, this is correct one. We cannot remove it, we can use it. This is theoretically correct. And also S2 and C3, this is a different pattern correlations. That's why we cannot use this correlation. We can use only M5 to M6, this is the same pattern correlation items. This is okay. And then we will check it out. These two correlations only, it works the modified or not. Here, modified acceptable 919902. SRMR is also 0.49. It's okay. RMSE somehow better, it's lower. And also chi-square is also good. This is pattern is correctly, this is also already good enough. This model is already acceptable. And then we will check it out another ways to improve after modification. And also residual. Residual means higher residual values are difficult, the problematic items. The residual value greater than or equal to 0.10 or 0.15, it's not good. It means should be the lower the better. That's why we will check it out the residual. I will run it again. Residual, I will comment in the output residual, residual. And then I will save it and give it running. Modified are the same, but I will check it out the residual value. Here the residual output. Here residual correlations, we should check it out. Here, model estimated correlation, residual correlation, residual covariance. Here study from residual correlations, residual for correlations, residual for correlation, these all here. We should check it out. Higher residual value greater than 0.1 pi or 0.1. We should check 0.15. We cannot see here, we cannot see. All are lower. Here a little bit 0.16. Minus or plus, we don't consider the minus sign or plus sign. These are correlation direction, that's why. But we should check the value 1 to 1. It means 1 to 1 means U1 and M4 we should correlate, but these are different items. That's why we will not use this one. We should use the same pattern. U1 is another factor, M4 is different factor. That's why we will not count these values. And also this one, residual correlations, almost are less than 0.1 pi. Here a little bit here, S3 and M7. This one a little bit higher, but the different items, different factors correlation, we don't count it. It means these residual values are also less than 0.1 pi, 0.1 pi. That's why we will not count it. Less than 0.1 pi. All are less than 0.1 pi. That's why from the perspective of residual correlations, this data is fine. No correlation is higher than 0.15. That's why we will think another ways to improve the model fit. The third way, correct estimator. Let us check the correct estimator. For example, in our model, here correct estimator, our data is continuous, our model is a normal distribution, we will use ML. Our model is not normal distribution, we will use maximum likelihood robust. Ordinate data, this one, this is a Bayesian CFA model, but not this in this CFA model. That's why we will change these three estimator different ways. And then which one improve more? Let us check it out. Estimator I use MLS because this is a Likert scale. ML I will use this ML. This is a normal distribution data continuous. I will save it and run again. Model fit information 919 CFI. Somehow just assertive, not very good enough, not very strong. This is chi-square values. It is assertive. It means chi-square by df values greater than, less than 0.5, less than 5. I mean, chi-square by df value should be less than 0.5. That's why it is okay, less than 0.5. SRMR, okay. RMSE is okay. We will check it out, different estimator. We use this time ML, next time MLR. I will save it and run it again. Modify information. Oh, great. CFI value somehow increase. 944, 0.944, 0.933. This model is the best fit. And also RMSE is quite good. Chi-square values, chi-square by df values less than 0.5. It's okay, great. SRMR. This model is absolutely fit. It is good. It means our data is non-normal. It means not in the normal distribution. That's why we use this robust maximum likelihood estimator. It's good. Is there any other way to improve the model fix? The fifth one is factor structure. We should check it out, factor overlap or high correlations, 1.8. I will check it out, the model factor structure. Oh, very high. Estimate. I will use 2 decimal to make it clear. Here, F1 and F2 correlations are more than 0.1. It is a problem. It means these two patterns are overlapping. These two patterns should combine or match the items. And also F1 and F4 more than 0.1.101. It has a problem. We should consider this F1 and F2, F1 and F4 to match items or to consider. That's why, and also to be clear, we should check it out, the values. Standardized results, let us keep going, model results, standardized. Here, F1 and here, that's a model correlation. F1 and F2 more than 1 point. F1 and F4 more than 1 point, but it's also F4 and F2 is also greater than 0.85. It is very strong correlation. It means the two patterns are highly correlated. It means the content between these two patterns are overlapping or quite similar for students. That's why we should consider to match the items or to combine the two patterns together. But I will go through this explanation, pattern matching or pattern structure explanation in the next video. But generally, most of the students like X, we don't want to combine because this is the theoretically strong patterns, 5 patterns in the questionnaire or in the theory. That's why we cannot combine the two patterns. How can we combine? At that time we should think, the validation is a sample dependent. Based on the different time, different participant, different context, it may change. Validation is not inherent. It means not depends on the previous structure or previous research or the developed questionnaire. We don't need to consider because it changed the context. That's why it may be the results are changeable. Based on the context data, we should validate it. That's what we can do based on the data. In this video, I show it how to improve the modified index. And also the last one is sample size. Small sample size, unstable estimates is quite difficult by small sample size. Mostly, the participants should be greater than more than 200 participants. But there's no common recommendation for the sample size. But it should be more than 200 participants. It is better for running the correct model fit or correct results. That's why we should take care in running CFA models. This is my presentation of improving the model fit in CFA model. If you want to know more, or if you don't catch some works or some explanation, if you don't understand, you can ask me by comments, something like that. Thank you very much.